I think is important. All right, so, as I said, these objects are made to be looked at, not just looked through. Again, all made of paper, but this leather is virtually covered with gold tooling. And so it would have been made by a bookmaker or a bookbinder, probably. Gorgeous object. It actually corresponds to a painting in a Roman private collection museum, and we think actually that this is associated with a cardinal who becomes a pope, who is in this family that still owns this museum, and it's the brother and sister who are not talking to each other anymore, alas, and so I can't find out more about this painting, which would really help me date this even better. So if you have a few kind thoughts to send in the way of Rome for sibling unification, I would appreciate that very much. Now, what can you actually see through this? Well, here is a setup looking down the hallway at this clock. So I aimed this telescope at the clock. It's just an ordinary clock this size. Well, that's what it looks like. That's a really small field of view. It's really hard to know what you're looking at. Here, you can see the numbers, but you can't tell the time. Here, you can tell the time, but you can't see the numbers. Now imagine trying to look at the moon. You can't even tell what you're looking at. This is a lot of work to be able to see anything. Now, the moon, I know it moves all the time, but at least it's sort of fixed, you can do. Imagine trying to spy on your neighbor or spy on a military operation using this. Sorry folks, utterly useless, right? I mean, it's only in rhetoric that you would describe the telescope being useful for military purposes. I mean, you can't see anything. All right, well, you know the good-looking guy, all right? Here is an absolutely lovely object that, by all principles, shouldn't exist. It's a Galilean telescope that's and according to all the principles, all the texts, all the writings, all the analyses, there should be no reason for this to exist, and yet here in our hot little hands is this beautiful object. Still don't know what's been. So this is one of our mysteries. I don't understand why it's there. I've actually found a couple of these really long Galilean telescopes. There's no reason for them. And yet there they are. I don't know what to do other than study it and think, well, this is just decoration. Sorry?
Is it? Maybe it's just for decoration.
It could be. It could be a demonstration of the concept. It certainly isn't very usable because by the time this is made, you have ones that you could actually use to spy. So we don't know. But on the tube here is a map of Rome from 1590s. Recycling paper. It's a work of art. It's not an instrument of scientific purpose. Most telescopes were not used to do science. All right, so here is sort of both the great discovery. This is probably the most important discovery we made this fall, and also a bit of embarrassment. The two often go hand in hand. I'll give you the triumph first because that's the goal. All right, so here is this nice object. My research colleague and I were looking at this and on display. And yeah, we should take a look at it. I mean, I don't know what it's going to be. I mean, people have looked at this before, but this is why we're obsessive compulsive, and we love our colleagues who are obsessive compulsive. You have to look at everything, right? So we took it apart, of course, and we realized, oh no, this is really like groundbreaking. Why? Well, it turns out to be a Keplerian telescope. The Keplerian has a positive lens by the object and a positive lens by the eye. It means the image is upside down. Well, if you're spying on your neighbor, depending on what they're doing, upside down, right side up, might not matter, but for spying, not so good. For astronomy, it doesn't really matter, right? Upside down is fine. So it is normally used as the astronomical telescope. That's what it's usually called. Trouble is, there are no examples of this anywhere. It's written, described by Kepler. No examples. because it has huge chromatic aberrations. The aberrations actually add, so it's terrible. So say all the books. Well, here we are at the Optical Museum in Jena, and stop you when you see the telescope. You see the telescope? Not yet? All right. See the telescope anywhere? See the telescope anywhere? Oh, see the telescope anywhere?
Oh, yeah.
All right, it's too big to see in the room, so here is what it looks like in the basement, with a nice gorilla pod and duct tape and electrical tape. And there it is. Set up to spy on a neighbor. Fortunately, nobody's home. And the image is upside down. And there's two lenses. It is unequivocally a Keplerian telescope. It is the only one in the world from the 17th century. We're not going to get a Nobel Prize for it, but we might get an article in the New York Times or something. This is actually huge. And so this was our proudest moment, having this telescope. All right, but here comes the humble, or at least the humiliating part. If you take a look at this telescope, it says tubus caelestis, astronomical tube. Duh, right? Well, we've seen this before. I looked through my pictures of visiting before, and I've been to this museum 4 times, and each time I've taken a picture of it, and it didn't hit me. And I talked to a few other of my colleagues who've been here before, and they didn't recognize it for what it is. It's ambiguous, right? Because it could be just a tube for looking at the heavens. Well, every telescope does this. But this is actually a technical word, right? It's actually an astronomical telescope. It's advertising and reinforcement. But it's an actually very important object, and proudly found it. All right, wrap up in a couple minutes, because I know you all need more. Remember, the earliest references in the Netherlands to telescopes talk about metal tubes. Other than that one in The Hague, that was sort of like the first one we found. Well, we snooped around this storage facility in Sweden, and I found half a dozen. All dating from about 1650, 1670. That's pretty cool. Snoop around this storage facility in Kassel and found another 4 or 5. Now, that means that those texts weren't lying, that tubes really were metal. So we have some more things that we're now trying to figure out about the role of metal. One of our observers pointed out that these metal tubes, they come together and are feathered, but they alternate. So one's like this, one's like that. So when you turn them, they don't get stuck together. I mean, how smart is that? But the most interesting one is this one, which, if you look at it, has a square lens. So we've just unlocked something that we'd suspected but didn't have any evidence for, which is that some of the early lenses were actually made out of sheet glass, plate glass, scored down in strips, made into squares, and then trimmed around the corners. We suspected it, but no evidence until now. So this is another great step forward. And if you look at the lens, it's really lousy, which of course means it's good for us. Assuming that these straight lines really indicate something, which now we're not entirely sure of, but depending who we talk to, it either is a sign or isn't a sign. All right, so last story. At the end of the 17th century, a new observatory gets built in Paris. And the question is, well, who gets to supply it? Because whoever supplies it, it's sort of like who gets to supply glass for the iPhone. Lots of competition. Nobody around here was involved in that competition. But let's just suppose lots is at stake. There are 2 candidates, 2 Italians, one named Campani, beautiful signature on the lens, and one named Davini. And they go at it because whoever wins this is going to get famous and have some real commissions. So they decide to have a competition. And the idea is you set up a target at a distance, and you look through your telescope to see if you can read the target. Well, in fact, we actually have two of those targets. Here's how one of them performed, here's how the other one performed. And you can tell who performed the best. Now, if you saw in the 17th century a line that said alpha and, I would imagine you would know omega would follow, right? You recognize this one? No, that's so dumb. Anybody recognize that? Oh, it's scientists, it's not humanities. In the middle of the journey of our lives, Dante. The first line of Dante. Now imagine you're in the 17th century and you see the words, "Nel vezzo del cammino." It's like, oh, well, everybody who's literate knows the rest of the line, right? And likewise with these. So, this isn't necessarily the best text, right? All you have to do is sort of get a little bit of it and you sort of do the rest. None of us have done this ever. Right? Well, they soon realized that's not quite the way to do it. And so they start coming up with some nonsense, random sequence of letters, and more random, which is actually the origins of our eye chart. They come from 17th century telescope competitions. That's the same thing we do now. So next time you get your eyes checked, you have a little piece of trivia with which to test your optician. That's part of that popular culture that telescopes in. All right. Well, I won't spend more time on this. The winner of that was Campani. We actually have lenses in the molds that he actually used, so we can start to reconstruct some of the techniques that he used, so we can understand better how he made them. And of course, they're all signed with this beautiful signature date. You see the bubbles in it. It's spectacular. All right, so wrap up. As I said, telescopes are part of popular culture, and what's the point here? You're kind of poking fun at this guy, right? Except the joke's sort of on you, because the best telescopes of the 17th century actually were backwards. But the biggest lens near the eye and the smallest one. This is the most important telescope find of the last 50 years, made by the person who invented, or who first used the three-lens eyepiece. And the three-lens eyepiece is over here, and the objective is there. So a little knowledge is a dangerous thing. We'll just leave it at that. This private collector has an extraordinary collection. One more piece of trivia, since I can't refuse a piece of trivia. This little bit here. The principle of the screw is known from Archimedes, right, lifting water and whatnot. But this little innovation is one we still use today. See, if you put this cap on, it's not going to always stay on, right? But if you use this little trick, namely, you take string, literally thread, you wrap it around in a spiral, you put the leather on it, you shrink it, you do the same thing here with wet leather, you screw it on, and the threads keep it together. And so the origin of threads, in the sense of screw threads, also comes from telescopes. Aren't you glad you came to me? Anyway, this is actually the origins of threaded screws, at least the threads. All right, what? The actual solution, as I said, to this is, is double glasswork, crown glass, and flint glass, two different properties, refraction and dispersion to compensate, and that comes around 1750. And I will tell you one last story. I lied, this is the last story. Invented by a lawyer by the name of Chester Moore Hall. It's Hall. This is a demonic device. who figured it out and didn't have any way to make these two lenses, one positive, one convex, because it required them to be precisely shaped. So he subcontracted one of them. Right, so this is what he's trying to make. He can't do it. He subcontracts it to one guy by the name of James Mann. He subcontracts the other one to a guy by the name of Scarlett. And since you can't read his name, I'll use that instead. See, there are literate. This is good. Right? So you have Mann and Scarlett. They're not going to bother. They're busy making money. And so they each subcontract to somebody else, and it happens to be the same person by the name George Bass. Bass figures it out. It's like, why would somebody, ooh, this is kind of cool. And he figures it out. And that shows up in the logo of Carl Zeiss at the end of the 19th century. All right. So, I really will wrap up now. Telescope, in popular culture, can also have this connotation of very narrow vision, right? Doesn't see any problem right behind him. War is brewing. So it can have connotation of positive intellectual brilliance or sheer stupidity, same instrument, depending on how you use it. It also has this connotation of gentility, of learning, of self-enablement, self-empowerment. Someone teaching his sister, or maybe the sister is teaching him. It's ambiguous. The same sketch, with just a little variation, has just a little slightly more body connotation. They're both looking at heavenly bodies with less work, but clearly looking in opposite directions. And in case you miss it, viewing the transit of Venus should make it fairly obvious what each of them is up to. My personal favorite. We have the wise eagle holding forth a lecture of some doofus here who is clearly rising above his station, trying to be clothed in education while his wife is canoodling right beside him, and he's too stupid to actually recognize what's going on. So, when you see telescopes, it's not about science, it's about popular culture. There's all sorts of things that are going on here above and beyond the science part of it. So, conclusion, these objects have a variety of functions. Part of what the well-educated, socially astute person would have perhaps in their pocket, or a walking stick, which of course, in my haste to leave my office, I left behind, and I was going to walk around it the whole time and then do the big reveal, which of course I just blew. But anyway, this is actually a walking stick that actually pops up, and you can say, I say, old chap, what's Venus up to these days? Right? And that's a very popular genre in the 19th century for having them on hand. All right. Thank you very much. And if you have questions,